So today we're going to talk about exponents. Okay, so these are important and vital for any subject in mathematics. You're going to need them. You need to know these rules, especially if you are moving to Algebra 2, because you will need to manipulate exponential functions utilizing these rules or laws, okay? So today I'm going to go over a couple rules and explanations about these particular laws or rules, okay? Any questions about what is going on right now? Or do we have any questions so far? All right, perfect. So let's actually, the first thing we want to discuss is the integer exponent. So if you guys would, in your in your participants guide, I'm looking at chapter 1, section 1, where it says exponents. Your homework is embedded inside of here where it says try me. So that would be on, let's see, page 3. And I'm probably going to add a couple more problems to that just so you guys know, okay? Because those are only 3 problems, and I want you guys to fully be engaged with how integers actually work, okay? I mean, exponents, I'm sorry. All right, so an integer exponent is the base of pretty much everything that we do when it comes down to exponents. We can expand on that at a later time. So what an integer exponent, the notation, so I'm going to int integer exponents. All right, it's going to look like some number. All right, and this is any real number. Okay, this is any real number. So it doesn't have to be just 2. And let's actually utilize a different color for my side notes so that way people don't get confused. So we have any real number. And this could be, for example, another example. So I would say this is example 1. I will give this example 2. So we can have an integer exponent as 1/2 raised to some variable n that is a positive integer. All right, so this, for example, positive integers, when we say positive integers, we're looking at numbers. So when we talk about positive integers, we're looking at the number 0, 1, 2, 3, 4, and so forth. I'm sorry. 1, 2, 3, 4, and so forth, okay? Positive integers. Now, this number n can also be the number 0 as well. We'll discuss that later. So we have 2 raised to the n power. So another example of what potentially could come out of this would be 2 to the 2nd power, okay? 2 to the 2nd power. Or we could say 1/2 to the 3rd power. And what this means is we're going to take this 2 and multiply it by itself 2 times. So it would be 2 times 2. We also look at 1/2 and say we're going to multiply that 1/2 by itself 3 times. So this is going to give me 1/2 times 1/2 times 1/2. So this is the notation and the functionality of what an integer exponent does, okay? So let's actually talk about what these parts mean, okay? Let's talk about what these parts mean. So our number 2 and the number 1/2. We call these numbers, when we're dealing with exponent, the base of the exponent. This is known as the base. Actually, let me use a different color so that it sticks out for you guys. We call this the base, okay? Base of the exponent. We call the numbers, I'm going to use blue for this. We call the letter n, my variable n, we call this the exponent. That is our exponent. That is the number of times we will multiply the base to itself. All right, do I have any questions about all of this jumbled stuff? Anybody have any questions? All right, Ryan, what's up? You can unmute yourself.
All right, in the little, I know they're not called parentheses, I forgot what they're called, but you have like 1, 2, 3, 4 written in red. What does that mean again? That's the positive integers?
So these are the positive set. So thank you for letting me know. So when you see parentheses in mathematics and its surrounding numbers, this is called the set, okay? The set, this is the notation for the set of numbers, okay? The set of numbers 1, 2, 3, 4. These are all of the positive integers. These are just your counting numbers or your natural numbers. Does that make sense? Ryan?
Oh yeah, it does. Thank you.
Okay, no problem. Jason, what's up?
I had the same question Ryan did. That's why I lowered my hand.
All right. Anybody else have any other questions? And can everyone see this portion of the board? All right, great. So now let's actually look at, now that we've learned exactly what an exponent does, let's actually talk about these laws now, okay? Let's talk about these laws.
Wait, hold on. Hold on. Oh, dang.
This will be recorded. I'll post it for you guys, okay?
Okay, appreciate it.
Also, did you guys get my, you can also follow my Instagram account. I'll post the link of it, but it's just PROFDEWAYNE-DIXON. So just prof Dwayne Dixon, okay? And you see how to spell my name, all lowercase. And it's public. I'll post problems. If you have any questions, direct message me and I'll actually answer the problem for you and post it as well, okay? My Algebra 2 students are also on there, so just understand that you have to read and filter as needed, okay? Do I have any questions about that?
Can you repeat the account name?
It's P as in Paul, O as in octopus, R as in Richard, F as in Francis, and then my name, Dwayne Dixon, all together. And it's DEWAYNE-DIXON. And if I feel like I need to, especially for my class, because I'm offering that service up, so you can you know, share that with your friends as well too, because I know they're probably struggling for tutoring and on some of these problems as well. So I'll help that. I'll help out with that. So I'll try to share that with Morehouse to get them to push that out. But in the meantime, word travels faster through social media, so you can share that. That's no problem. Okay. All right, moving on. So the first law that we want to discuss is something called product law. Okay. Oh man, gotta get some expos. Product law. Now, product law is very handy, okay? But understand, equal means it can go, when we see the equal symbol, it's true going in both directions, okay? It goes this way, and it also is true going this way. All right? So that means A, if I have a product law, I'm gonna erase this so that way we don't get confused about what this is. So if I have the product between the same basis with the exact same base raised to exponents, okay? So I have a to the n times a to the m. The bases are exactly the same. Okay, the bases are exactly the same for product law to work. So a to the n times a to the m is simply the same thing as saying a raised to the n plus m. All right, do I have any, well, let's look at a numeric example before I take any questions, okay? So let's look at how this actually works. Now, a here, just so everyone understands, a is my base, and from our integer exponents definition, this number here can be any real number. Okay, that could be any real number that we may choose it to be. All right, so let's look at an example really quick. So let's say we have 2 raised to the 3rd power. And we're going to multiply this by 2 raised to the 4th power. Let's not go that high. Let's say 2nd power. Okay. What we're now going to do is break this apart. So I'm going to first expand. The exponent, which we call expanded form, okay? I'm going to expand my exponent, which we call expanded form. So 2 to the 3rd in expanded form is going to be nothing but 2 times 2 times 2. So just defining what 2 to the 3rd actually is, giving me the functionality of what this means. That's what we are doing when we place it in expanded form. We keep our operation the exact same. And now we expand my final exponent, which is 2 squared. So its expanded form is 2 times 2. Now we want to rewrite this as an exponent. This gives me my base of 2 being multiplied to itself 1, 2, 3, 4, 5 times. So the final number of times that we are multiplying the same base will be my exponent. Now, by the laws, it states that if the bases are exactly the same, and 2 and 2 are the exact same numbers, so therefore my bases are exactly the same, what we are able to do with the exponents are add them together. This is the rule. It will always be true. So let's look at that. So 2 to the 3rd times 2 to the 2nd is going to be equal to 2 raised to the 3 plus 2, which gives me 2 to the 5th power. Do I have any questions? Yes, sir, Sadiq. You gonna mute yourself?
Can you hear me?
Yes.
My computer's having trouble. Can I restart and come back?
Yeah, that's fine. You don't have to ask that. Anybody else have a question? Yes, sir, Sean.
Yeah, so what do we do if the base isn't the same?
Then can we utilize product law?
Or that we would just multiply the exponents together?
No, we don't do anything with them. We can't, if we're multiplying them, if we're multiplying bases that aren't the same, we just simplify. So we would expand it out as such, but we cannot add those exponents together because this law says the basis must be exactly the what?
The same.
The same. So that's going to be true for the most part with all of these rules I'm going to go over, okay?
All right.
Any other questions? Any other questions? All right, perfect. So let's go ahead, Brandon. I saw you had your hand up earlier. Were you good to go?
Yeah, you answered my question.
Perfect. All right, so I guess the numeric version works, okay? Now, the thing is this, okay? College algebra, you know, so the integer exponent is true. Okay, this is true for integers. These are all integers, these are all integer exponents. The product law also works with rational exponents as well, okay? As long as the bases are the same. And when I say rational, I mean numbers like 1/3. So we're talking about now my fractions. So side note here, n can be a rational number or simply a fraction, okay? And the law is still the exact same. So don't get confused. Just because I may say, what is x to the 1/2 times x to the 3rd, don't feel that, that something's different there because this number is now a fraction. You can still operate the exact same way. You just have to add them together. And of course, for you guys, you know, you have to keep it in fraction form for me, all right? And if you have any questions about how to write something in fraction form, please feel free to send me a DM. You know, that's going to be the way of communication. And then I'll tell you to set up a You Can Book Me, okay? So I sent out a link already on Blackboard. You can book me for my office hours. They're available, okay? Please be mindful that if you have to cancel, please give me some type of notice for that. All right. Give me at least an hour notice in order to cancel. Okay. Yes, sir, Ryan.
So everything's gonna be done off of like Instagram now.
So no, I'm still going to hold Zoom calls.
Okay.
You're going to. It's easier for me instead of filtering through Outlook. It's easier for me to look at the messages that comes in with the image. It's easier to attach an image through Instagram, if that makes sense. And so you guys can turn in your exams to me via Blackboard, or you can send me, if I ask for a quick quiz, you know, you can take a picture of it really quickly and just shoot it to me direct message in Instagram. Does that make sense? Did I answer your question?
Yes, sir. Yes, sir, you did.
All right, perfect. All right, so moving on. I want to discuss the next law, which is quotient law, okay? So as we know, the inverse of multiplication is division. And so therefore, we should utilize the inverse of addition, which is subtraction, when we deal with quotient law. All right, so with quotient law, we have some exponent, a to the n power, that is being divided by a to the nth power. And what we are going to do, and notice here, my bases are the exact same variable, so therefore these numbers must be the exact same, okay? This is only true when my bases are exactly the same. So this is going to be equal to a to the n minus m. we always want to make sure the first number that appears in this expression is the numerator's exponent, not the denominator. So the first number that appears in my n minus m is always going to be the numerator's exponent. So let's look at an example. Let's say I have 2 to the 4th power being divided by 2 squared. Okay? This is going to be equal to 2 to the 4th. Let's actually do this in expanded form first so we can see how this works. So let's expand my numerator. Okay? Let's expand my numerator. So that's going to be equal to 2 times 2 times 2 times 2. And after we expand my denominator, we end up with 2 times 2. And now we're going to simplify this fraction. So 2 divided by 2 gives me 1. 2 divided by 2 gives me 1 as well. So 1 times 1 is just simply 1. So therefore, we have a 1 also in the denominator. 1 times 1 is equal to 1. So times 1 is still going to be there. Or you can simply say, okay, well, I can rewrite this to make, to make sure that there are the same number of numbers in my numerator and the same number of numbers in my denominator. So now what this is now going to give me is 2 times 2 when we condense it. So the process of going from 2 times 2 times 2 is equal to 2 to the 3rd. So the process of going from expanded form to exponential form, we call this expanded to exponential. We call this condensing. So when I ask to go from expanded form to condensed form, we are going to just push this to an integer exponent or an exponent. Okay, so I see 2 hands. So let's see. Yes, sir, Delvin.
I was just wondering down there where it says like the 3 2s, 2 to the 2 cubed. I was wondering how did you get 3 2s if we only had 2 up top?
No. Okay, so I guess maybe I should keep it the exact same. Yeah, that would make sense. Thank you. This is all new for me. This was all right, so I'll keep it the exact same. So 2 times 2 is equal to 2 squared. I thought about the notation, the language that I was using, and it might have confused you. So when I say condensed form, we're just taking our expanded form and moving to our exponential form. Thank you. That actually was a good idea. So therefore, we know what 2 times 2 is. In condensed form, that's going to be equal to 2 squared. Okay. Jason, what's up for me?
Like when you had 2 to the 9th, how come you only wrote 4 2s across the top?
2 to the 9th. This is a 4.
Yeah. Oh, okay. My bad.
No, you're fine. This is a 4. It might. I'm glad you said that. It might have looked like a 9. So that's a 4. All right. So therefore, 2 times 2 is equal to 2 squared. So 1 times 1 is also going to be 1 squared, which we know that, okay, well, 1 squared is simply just 1, but we cannot apply quotient law here because these two numbers are not the what? Same. So here, my bases must be the same in order to use quotient law. My base in my numerator is 2. My base in my denominator is 1. My exponents are the same, yes, but my bases are not. Yes, sir, Delvin.
I didn't have any more questions.
Okay, can you lower your hand for me now? Because it's showing up that you have your hand raised. All right, perfect, thank you. All right, so now when we simplify this, let's leave this as an exponential so we can see how the quotient law works. But we know 1 squared is simply just 1. So we have 2 squared divided by 1, which gives me my final answer of just 2 squared, okay? Now let's look at this in quotient law. Let's look at this in utilizing the quotient law. I really wish I had a little bit more board. So I will write this in black. Actually, let's use blue so that way we can see it. So applying the quotient law, and I'm going to work my way vertically. We have 2 to the 4th power being divided by 2 squared. What quotient law states is we can simply subtract the denominator's exponent from the numerator. So that's going to be equal to 2 raised to the 4 minus 2 power, which gives me 2 squared. So my numbers are exactly the same. My answers are exactly the same, utilizing both expanded form and using my exponential laws. Any questions? Any questions? Now I'm going to slide something in here. A lot of people like to separate it, but I like to introduce it after quotient law, because what if, let's say, it was 2 minus 4? What if I had 2 squared divided by 2 to the 4th power? So let's actually look at that. Let's actually look at that example. And again, I'm going to post this so you don't have to worry about really drastically writing things quickly. I cannot wait until I get a grip of this whole video recording thing. Any questions on quotient law so far, though? Please ask them. All right, so let's look at an example where we have 2 squared being divided by 2 to the 4th power. So what we want to do is expand this out, okay? So this will give me 2 times 2 being divided by 2 times 2 times 2 times 2. So let's make sure we have the same number of numbers being multiplied to in the numerator as the same as in the denominator. So let's just add this times 1, because any number times 1 is just going to give you itself. So now, what we can do is simplify these. And so what we end up with is 2 being divided by 2, which gives us 1. And then we have 2 divided by 2, which gives us 1. And so now we have 1 squared in my numerator, but then we have 2 squared in my denominator. And once we simplify this out, we end up with 1 over 2 squared. Now let's look at the quotient law itself. So what it tells us to do is subtract the numbers. So what we're going to have is 2 squared divided by 2 to the 4th is equal to 2 to the 2nd minus 4. And 2 minus 4 is going to give me a value of -2. Well, what do we do when we have a negative exponent? Well, we know these laws are true. We just showed it was true with the first quotient law, quotient example. So now we can assume it just automatically we can show, if you're in abstract algebra, if you're math majors, there's an extensive proof to this. I just want to give a side note to this. This is just proving, you can't prove anything by numbers, okay? So if you're a math major, understand you cannot prove anything by numbers, okay? It must be true for every set set that you say it's true for, okay? You have to prove it across all numbers in that set. Just throwing that out there. Yes, Jalen?
I thought we couldn't have negative exponents in that. You wanted us to flip.
Exactly. We can't have negative exponents. So because we can't have negative exponents, I'm introducing another law. It is called the Negative Exponent Law. And to get rid of negative exponents, as you can see, we have the exact same base in the denominator, but my exponent is positive instead of negative. So we can say 2 to the, sorry, let's not use 2 because this is true across the board. So we can say a to a negative exponent n. Let me separate that because it looks like that's all one thing. Is equal to 1 over that exact same base, but we're going to now change my exponent positive. So these are the exact same numbers. Okay, any questions about that? And so anytime we see a negative exponent, we can automatically jump to this format. Okay, except it here in algebra. Does that make sense to people? Hand raise if that makes sense for me. Raise your hand if that makes sense. All right, I got 16 people, 4, 6, 7. Only 7 out of 16 people, okay. All right, so only 7 out of 16, this makes sense to. So let's see, 8. So what is confusing between these two? Someone. So everyone lower your hand if you understand it. Someone, please, if you have any questions, ask me. Okay, Ryan, what's the question?
So it looked like you just put the 1 over the 8 with the n exponent when you have a negative exponent.
Correct. So you
1 over.
Go ahead.
Okay.
What you were saying?
No, I was just saying, like, is that what you do every time? When you
Every time, yes. So every time you have a negative exponent, we place it inside of the denominator and make sure the exponent turns positive.
Gotcha.
Now let's expand that exponent rule though, because you know, what if the exponent is in the denominator and is negative, right?
Right.
All right. So let's look at that.
Right.
All right. Give me 1 second. I'm about to erase the quotient law. Can everyone mute themselves for me? Any other questions about this before I move on? All right, Sean.
So is it just like when you have like a negative and you just flip it? Is that kind of what we're doing?
You're not flipping it. What you're doing is this is over 1, right? Any number that does not have a denominator, we can make it a fraction just by dividing it by 1. So what we call that is reciprocating. So you're going to take the reciprocal, which means, I guess in your terms, flip it. So we can flip the numerator and the denominator, but we want to make sure the exponent turns positive. So just make sure it's positive. That's it.
Yeah, that's what I meant. We
Yeah,
reciprocate it, and then it's going to be positive.
Which was correct. So when you see the word reciprocal, that's that flipping term you use, okay? When it comes to fractions, because we're going to need that when you're multiplying fractions, actually in a couple minutes, okay?
Okay.
All right. So let's look at the example where we have the negative inside of the denominator. So let's say we have 1 over 2 to the negative second power. Okay, let's say we have 1 over 2 to the negative second power. Let me write this in a different color. Sorry. And this is another example of negative exponents. So let's say I have 1 over 2 to the negative second power. Well, what we want to do is rewrite this, and let's change the number from 2 to -3, okay? So let's look at the negative third power. So what we're going to do is we have a negative exponent. We're going to utilize the negative exponent law. So what that says is if we have a negative exponent, we're just going to reciprocate the fraction and make the exponent positive. So we're going to do the exact same thing. We're going to divide this by 1. 2 to the negative third divided by 1 is the same thing as saying we have done nothing to this 1. So it comes straight across. 1 divided by 1 over 2 to the third. So we utilize the negative reciprocal law only in the denominator. Only in the denominator. We utilize our negative exponent law, not negative reciprocal law, sorry. Negative exponent law, that's what we utilize. And so now we have two fractions dividing each other, because we can rewrite 1 as a fraction. So with that, we can rewrite 1 as 1 divided by 1 being divided by 1 divided by 2/3. We're going to keep it the same. And so now we are dividing fractions. Now we are dividing fractions. So the side work for this, I'm going to do this on the side. How are you going to divide two fractions? Well, we're going to say 1 divided by 1. We're going to keep that the same. So keep the numerator the same. Times, we're going to change my division symbol to its inverse, which is multiplication. So keep change. And then we're going to flip, as Sean like to say, flip the denominator's fraction. So that means my 1 over 2/3, we're going to take the reciprocal of it, and that's going to give me 2 to the third divided by 1. Keep, change, flip, or reciprocate. Okay? And so with that, we end up with, and once we have multiplication, we multiply fractions straight across. So 1 times 2/3 give me 2/3, and 1 times 1 is 1. And so we can actually simplify 2/3 divided by 1 as giving me my final answer of simply just 2 to the third power. All right, is there any questions about what happens when my negative exponent is inside of the denominator? And I'm going to divide this by 1 in red, so that way we know that was not given. You will only be given the negative exponent in the denominator. It is your responsibility to see that this negative exponent is being divided by 1. This is understood, okay? Any questions? Please, if you have any questions, let me know. Any questions? I'm assuming not. All right, perfect. So after introducing the negative exponent law, let's say with the quotient rule, I'm going to give another example of the quotient rule, which is going to introduce another law for us. All right. So another example of the quotient rule. Let's say we have, and I'm going to change the base, 3 to the third power, let's not use 3, 4 to the third power divided by 4 to the third power. Well, this is equal to an expanded form, 4 times 4 times 4. divided by 4 times 4 times 4. And after we simplify, we end up with 4 divided by 4 is 1, 4 divided by 4 is 1, 4 divided by 4 is 1. When we multiply these ones together, we end up with simply 1. So if we look at the quotient rule, that states 4 to the third power divided by 4 to the third power is the same thing as saying 4 to the third minus 3. And 3 minus 3 is equal to 0. So 4 raised to the 0 power, based on our work above, is equal to 1. So this gives me my next law, which is the 0 law. The 0 law. And that states any number raised to the 0 power is always going to give you a value of positive 1. Any number raised to the 0 power is always going to give you a value of positive 1. Are there any questions about this? Any questions? So anytime when you're showing me work, you see an exponent, a base raised to the 0 power, it's understood to be 1. So whatever you're multiplying it by, it needs to be itself. Okay? Unless you're adding it, then it just stays +1 or subtracting it. Any questions? Yes, sir, Sadiq?
How exactly does it factor out to be 1?
Because when we expand, this is an example here, the proof is kind of intense to show that it's true for all, because we will have to be able to take the product, the product series. But here's an example of, sorry, when the values, when we use quotient law, when we subtract the same numbers, we're going to get what number? 0. So this number, 4 to the third divided by 4 to the third, this is how it looks in expanded form. That's the same thing as saying 4 times 4 times 4. And then the denominator, 4 times 4 times 4 times 4. And we know when we have the exact same number dividing itself, it's going to give us a value of 1. So 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. And all of these ones times itself is just going to give me a value of 1. And this is true, whatever exponent I give you. Yes.
So 0 is the same as just the base being multiplied by itself?
Say it again.
So the 0 exponent is basically saying the base is being multiplied by itself.
The 0 exponent means when the bases are the exact same, your exponents are also the exact same. Does that make sense? When you're dividing, the 0 exponent means that your base, which is a, are exactly the same. So for this example, it just so happens to be 4. And the 0 by quotient law means we're subtracting the exact same number. So your exponents must also be the exact same. Does that make sense?
Yes.
All right. All right. Any other questions? Any other questions? All right, perfect. So this is its own rule. Any number raised to the 0 power is equal to 1. All right. So, got some time to go. This is gonna be a long video. Goodness gracious. You will need this law as well. It's a very nice law because everyone decides when they're using exponents. I've seen it happen a lot when I see people, when it says x plus 2 squared, okay? some people want to say, well, this is the same thing as saying x squared plus 4 squared. This is not true. This is not the case. This is not the case. The only time we're able to utilize moving the exponents in that way is when we have a product. I'm sorry, when we have the power, sorry, wrong name, power of a product. So, example of this would be 2x squared. Now we can say this is equal to 2 squared x squared. When we have x plus 2 squared, this is the same thing as saying x plus 2 times x plus 2. Everything inside of the parentheses that is being squared, we're going to multiply everything inside of the parentheses times itself 2 times, or whatever that value is. Okay? Any questions about this? I'm about to give the definition of the actual power of a product in just one moment, but any questions about why this and this are not the same and why this is this? Okay. Because I see that a lot. You guys make that mistake a lot. So let's look at what a power of a product is. Let's look at that. So what that states is any two numbers, A, B, any two numbers that we are raising to a power n is simply equal to that number A raised to the nth power times that number B raised to the nth power. Let's look at an example. And we're going to look at numbers, okay? So understand that variables are nothing but numbers, okay? So this also works with variables. I will give it an all-inclusive variable example very soon, okay? So let's look at 2 times 3 to the third power. Well, we could rewrite 2 times 3 to the third power as saying 2 times 3 times itself 3 times. So this is going to be equal to 2 times 3 times 2 times 3 times 2 times 3. Any questions about how I got from here to here? All right. So this, because we're multiplying all of this, we can rearrange these numbers however we want to rearrange them. So I want to pull all of my 2's to the front, and I'll push all of my 3's to the back of this expression. So we're going to end up with 2 times 2 times 2 times 3 times 3 times 3. Any questions about how I went from here to here? All right, so now we can go from expanded form to condensed form, which will give me 2 to the third power times 3 to the third power. Any questions about how I got from here to here? I just condensed this line. I condensed this line to exponential form. All right, so let's actually see what's really going on here, though. When you just have a number, 2, when you just have a number 2, it's understood that the exponent is 1. Also with the number 3, it is understood that the exponent is 1. So because of that, we're really just using the power rule just on both of these numbers because we're multiplying them together. So really what we are doing, we are saying that this is the same thing as saying 2 times 1, raised to the 1 times 3 power times, because the operation stays the same, 3 raised to the first times 3 power, and 1 times 3 gives me 3 times 1 times 3 is 3. So as we can see, this and this are exactly the same. Any questions? Notice, what operation is this? Multiplication, not addition, not subtraction. It's multiplication. So just how we have power of a product, we also have power of a quotient. All right. We have power of a quotient. And so what that states is any exponent, A being divided by, any base A being divided by B raised to the nth power is going to be the same thing as saying A to the n being divided by B to the n. So let's look at an example. Let's say we have 2 divided by 3 to the 4th power. This looks like a 9 maybe, so it's to the 4th. This is going to be equal to 2 divided by 3 times 2 divided by 3 times 2 divided by 3 times 2 divided by 3 4 times, because we're raising 2/3 to the 4th power. And so now we can see that since we're multiplying fractions, we're going to multiply straight across. So my numerators are going to all be multiplied to each other, and my denominators are all going to be multiplied to each other. So that gives me 2 times 2 times 2 times 2 being divided by 3 times 3 times 3 times 3. Well, going from expanded form to condensed form is going to be 2 to the 4th power in my numerator and 3 to the 4th power in my denominator. Now, using the quotient law, the power of a quotient, we have 2 divided by 3 to the 4th power. It's understood that 2 is raised to the 1st power, and understood that 3 is raised to the 1st power as well. And what we're going to do is say 2 times 2 raised to the 1st times 4 is the exact same thing as divided by 3 raised to the 1st times 4. And 1 times 4 gives us a value of 4, and 1 times 4 gives me a value of 3. So as we can see, my answer here and my answer here are exactly the same. All right, so it works. Yes, sir, Jason?
So basically, do you use the like the original part right there? Do you use it kind of as a way to check your work to make sure your answer is right?
So once you understand this, you can just utilize this. This is the actual law, so this will be true every single time. Does that make sense?
Yes.
This is just the process as to why it's correct.
Okay.
Okay, okay, so again, it's the process. It's not the proof. It's the process. Does that make sense?
Yes, sir.
Okay. Any other questions? So we got laws of exponents like that. We good? Because that's the last law. Now we can get to some examples. Yes, sir, Jalen?
So on the test, since it seems like kind of straightforward, can we just like write the final answer, or will you take off points for that?
No, I will take off points. I need to see, especially if I'm testing laws of exponents. If I tell you to simplify it, I give, like I'm about to give an example of what a test question will look like.
Okay.
Okay, so in the process I take, I will take a picture of this afterwards and post it on Instagram so you can see the process, okay? Because I know that the problems are going up and they're coming down kind of quick. So you can at least have that. It's kind of like a virtual notebook. All right, any questions? All right, so let's actually look at an example of this in an actual play, okay? And let's see, what time do I have? Because I don't want to run over. I know y'all might have class immediately after. Again, utilize that you can book me for office hours, okay? Utilize that you can book me for office hours. So we got some time. All right, so example 2 on in your study guide, example 2, we have -2 x to the 3rd y to the 4th times 6 x y to the 2nd. Okay, we're going to just utilize the laws or rules here, okay? Well, the operation between all of these is multiplication, so we could really just drop the multiplication symbol. So this gives me -2 times x to the 3rd times y to the 4th, and I said the wrong thing. We can drop the parentheses and multiply all of these numbers together. Okay, I said drop the multiplication symbol. Forgive me on that. We can drop the parentheses and multiply all these terms together because these two expressions are being multiplied together. So we can just drop the parentheses and just multiply straight across. So I now have all of my terms being multiplied to each other without the parentheses. Now I want to join like terms, okay? So we have an integer, we have another integer. We have a real number and another real number. So let's pull those together. -2 times 6. All right, so we utilized the -2 and the 6. Now let's multiply this entire thing by x to the 3rd. We have a like term of simply x. So we're now going to multiply this by x. And then my final two terms both have the exact same base. So we're now going to multiply this by y to the 4th times y to the 2nd. And I said like terms. These are not like terms. These are like bases, okay? Like bases. They're not like terms because the exponents are not exactly the same. Okay, any questions about what I just said? That's a correction of my language. Any questions about what I just said? These are not like terms, they have like bases, my variables. Perfect, okay? So now we just simply simplify now. So we know -2 times 6 is going to be -12 times, now we're going to use product law because we are multiplying the exact same bases together. Well, we know that x is the same thing as saying x to the 1st power. And by product law, what it says is we're going to add the exponents. So we're going to have this be x to the 3rd plus 1 power. times y to the 4 plus 2 power, because we are also multiplying my y's together. So I got from here to here by using product law. And now we simplify to give me negative 12 x to the 4th, y to the 6th. Any questions? It's my final answer. Any questions? And so the directions for this would be simplified. When you see the word simplify, and I'm just going to give you this expression, you are going to utilize the rules or laws of exponents to come up with your final simplest answer. So that means we should only have one of the same bases, okay? Yes, sir, Ryan.
Where the exponents say 3, is that 3 plus 1 or 3 minus 1?
3 plus 1, yes.
Okay.
Sorry, that does
It's
look
kind
like
no, it's not your fault. It's kind of blurry. I get at least on my end.
Is it blurry on others?
It's a little blurry on mine too.
What
Yeah,
about
same here.
What about
I think
now?
it's the quality.
No, I don't know what to do about that, man. This is the best I can do for you guys. All right, any other questions? Like I said, I'll post a picture on this on Instagram. And yeah, sorry about that.
It's good on my end. It's not really blurry for me. It's clear.
Okay.
Yeah, it's
It might be,
clear now. It's clear. It's clear.
so it might have been the connection with the internet.
Yeah.
All right, any questions though? All right, so let me take a picture of this really quick before I move on. Oh my, it's suspicious. Okay, so now I'm not gonna do it that way. On my desk. All right. So now let's look at another example. Welcome back there. We're going to do the exact same thing. We're going to simplify this expression, okay? I wish that I had my notepad, because then I could do this on the whiteboard. I don't like how it's showing on my notepad when I use my stylus. All right, so the example is x squared being divided by x to the 3rd power. So what we're going to utilize here, we have the exact same basis. We're dividing, so we're going to use quotient law. So that will be x to the 2 minus 3. And 2 minus 3 gives me a value of negative 1. Okay, so to go from here to here, I utilize quotient law. Well, now we have a negative exponent. We don't like negative exponents. So what we want to do is now utilize our negative exponent law, which says that we're going to reciprocate the fraction and make the exponent positive. So this is going to be equal to 1 over x to the 1st power. And this was done by the negative exponent law. But any number raised to the 1st power is simply itself. So we can simplify this to just give me a final answer of 1 over x. Any questions? Any questions? Yes, sir, Ryan.
This is an example of quotient law and negative.
A negative
like,
exponent. So when we get a negative exponent, we must utilize the negative exponent law. Anytime you have a negative exponent, you must utilize the negative exponent law. Any other questions? Any other questions? All right, so I'm gonna do one more example. This is just, because I like you guys a little bit, right? So I'm gonna give you guys one more good example so we can see how this works, just to make sure we don't have any other problems with laws of exponents. All right, so this is not located inside of your study packet. This is not located inside of that participant's guide, okay? So this example is to simplify negative 3x squared times y divided by x, all raised to the 5th power. Okay, so this would be a test question, right? This is beautiful. We have everything that's necessary to be successful here. So the first thing I will utilize to get rid of this 5 on the outside in the parentheses is the power of a quotient law. So this is going to be equal to, since all of this is raised to the 5th power, I'm going to include parentheses around this. So negative 3 x squared y raised to the 5th, all being divided by x to the 5th. Any questions about how I got from here to here? And this is power of a quotient law. This is the first law we use, power of a quotient. Let me use that as a capital Q. There we go. Any questions? Okay. So now, in my numerator, we have all of these numbers with different bases being raised to the 5th power. So this is going to give me, and I'll write it in purple so that way we can color code these steps. It's understood that negative 3, all numbers that do not have an exponent, is always going to be raised to the 1st power as well. Why it does not have an exponent, or so we see, it's raised to the 1st power as well. So now what we're going to use is power of a product, because all of these numbers are being multiplied together, which is going to give me negative 3 to the 5th power times x to the 10th power times y to the 5th power, all divided by x to the 5th. So my second step was to use power of a product law. Any questions on how I got from here to here? Any questions about how I got from step 2 to step 3? Yes, sir, Sean.
So are we not multiplying x to the 5? Oh no, never mind. It's separate. Never mind.
Okay. And
I was
so,
talking about the denominator.
oh yeah. No. We utilize this when we utilize power of a quotient law. So my 5 went to my numerator. My 5 also went to my denominator.
Yeah.
We're just utilizing the law. So we're not going to expand this out. We have accepted that all of these laws and exponents are true.
All right.
All right?
Yeah.
Perfect. All right. Any other questions before I move on? Okay, so now we have here -3 raised to the 5th power times x to the 10th times y to the 5th being divided by x to the 5th. Well, we now have common bases in both the numerator and the denominator. So now we have to simplify that. So what that's going to give us is quotient law. We're going to utilize the quotient law there. So we're going to have -3 raised to the 5th times x to the, for quotient law, we subtract the exponent. So 10 minus 5 gives me 5. Rewrite that 5 because I look like I erased it by accident. Times, there is no variable y in my denominator, so it just stays y to the 5th power. And we got here by quotient law. We got here by quotient law. And so after we do all of our math, there's no common basis here anymore. We don't have any common basis, so we can simplify this. So we know -3 raised to the 5th power, well, we might not know it, but it's equal to -243 times x to the 5th times y to the 5th. This is your final answer. Any questions? Yes, sir, Zero.
So in order to get x to the 5th power, you just subtracted the.
Yep, I utilize quotient law, and quotient law states that we're going to take the exponent in the numerator and subtract the exponent in the denominator. So 10 minus 5 gave me a value of 5.
Okay.
Any other questions? Any other questions?
Yes, sir.